Good morning, everyone. This is going to be the second part of our review for Unit 3. So the second half really focused on exponential models, exploring laws, solving equations, that sort of thing. So in this review note, we're just going to run down the rules and go over how those things work. Okay. So the first thing is our exponent laws. Okay, so let's go through the rules here. So one of them is that, right, anything to the power of 0 is equal to 1. That's a special case. Okay, if you have power 0, it's always equal to 1. Oh, pardon me. Okay, our product law, okay, which is if you have two powers with the same base, you're going to multiply those together, right? So as a side example, right, if I had something like 7 squared times 7 to the 4, right, we know we just add those exponents together and you would get 7 to the power of 6. Okay, our next rule is the quotient law. If you're dividing powers, you would subtract the exponents. So if I went with the same thing here, like if I had 7 squared, but I was dividing it by 7 to the 4, okay, I'd subtract. So 2 take away 4 would give me -2 as my exponent. Okay, our third rule, I'm sure that says fourth in this list, is power to a power, right? When you have a power and you raise it to another power, you have to multiply the exponents together. So again, if I took my same numbers here, I have 7 squared, but I'm going to raise it to the power of 4, then I would get 7 to the power of 8. Okay, and our last one is how to deal with a negative exponent. So if you see something with a negative, like above there, I had 7 to the -2. Okay, a way you can simplify that is it becomes 1 over 7 squared. Okay, so those are those 5 exponent rules. Again, this might be a good place to pause the video, make sure everyone got that written down, and then we'll go on to the next thing. The next thing we looked at in this unit were what happens if your exponents are irrational, right? You have fractions or decimals instead of whole numbers for your exponents. Okay, so for the basic case, right, so x to the 1 over n, okay, it becomes the nth root of x, right? So for example, if I had, let's say, 27 to the power of 1/3, okay, that's the same as doing the cube root of 27, which if I ran it through my calculator would equal 3. Okay, so the fraction, the denominator means the root. Okay. More generally, okay, if we have a numerator and denominator in that fraction, okay, then the numerator is on the outside, so still raised to that power, and then the denominator comes the root. Okay, you can also write it like this with the power on the inside. They mean kind of the same thing. Okay, again, for example, if I went back to this one and said, what's 27 to the 2/3? Okay, that means to take the cube root of 27 and then square it afterwards. Okay, let me fix that. Okay, take the cube root of 720 first and then square it after. So cube root of 27 is 3, square it, and that equals 9. Okay, so that's what those fraction exponents mean. Okay, the next major topic we looked at was solving equations that have variables in the exponent. Okay, so the main goal here is to get things with the same base. So for my first equation, 2 to the power of x plus 1 is equal to 2 to the 4. Okay, I note that, right, they both have a 2. They have the same base. Okay, so that means that the two exponents have to be equal to each other. Okay, so that's my next line. It's just to say my exponent on the left, x plus 1, is equal to my exponent on the right, which is 4. Okay, and now we're just doing some algebra to solve for x. Okay, so my next step would be to bring the 1 across. Okay, and I think when we did this on the board the other day, I only showed it coming over to the other side, but it's the same thing that I've shown there. Okay, right, I bring the 1 over, so that means x is equal to 3. Okay, and just on the side here, a quick way you can check to make sure you did that right, of course, is to go back to the top. So, right, my thing on the left said 2 to the x plus 1, so 2 to the 3 plus 1, right, which would equal 3 plus 1 is equal to 4. And that's what the other side said. It's supposed to be equal to 2 to the 4. So that means we got that right. Okay, if they do not have the same base, so here's 3 to the 2x plus 3 equals 27 to the x plus 1. Okay, if they don't have the same base, then you have to make some adjustments to get them into the same base. So in this case, right, 3 does go into 27. So on the side, we think what power of 3 is equal to 27? And after playing around for a bit, right, 3 to the power of 3 is equal to 27. So then we make a replacement. Okay, I replace my 27 with 3 to the power of 3. Okay, my next step, okay, is to use the power to a power rule here. Right? It says I have to multiply my exponents, so I have to expand this 3 into my other exponent. So that means I got 3x plus 3 on that side. Okay, now that I have the same base, right, both bases are 3, I can drop my base. So I have 2x plus 3 is equal to 3x plus 3. Okay, from here, there's multiple paths to solve this. Okay, but typically we try to get the x's together first. So again, I'll tidy this up a bit. If I remove the 3x over, okay, I'm going to get negative 3x on the other side. Okay, and then 2x take away 3x is equal to negative 1x. Okay, now I need to get the 3's together. So when I bring the 3 across, okay, I have 3 take away 3. So I have negative 1x is equal to 0. Okay, and if I divide both sides by negative 1, I still have 0. So that means x is equal to 0. And again, if you want to do a quick check, right, we could plug it back into original equation. Okay, on the one side, I had 3 to the power of 2x plus 3. So that would be 3 times 2, pardon me. Okay, and again, this checking step, you don't have to do the checking step. Okay, like I wouldn't ask for it on a test, but, all right, so I have 0 plus 3 is 3, that equals 27. Okay, but, you know, it's good for you if you have time to check and see if you got it right to check. Okay, on the other side, I originally had 27 plus x of x plus 1, so 0 plus 1. So that's 27 to the 1, which is 27. Okay, so our final case with exponential equations is what do you do when the base cannot be resolved, right? Like I can't write 7 as 2 to the power of something into the x equals 7. Okay, so we discussed in class, like there's a few ways you can do this. Okay, you could do this with a guess and check. Like start plugging in powers for x and you'll have to get into decimals and do that until it gets reasonably close to 7. Okay, you could graph both sides in decimals, okay, right? Graph the equations y equals 2 to the x and y equals 7 okay, and see where they cross. Okay, and that will also tell you what's going on. Okay, the third method is logarithms. So I'm going to review that on the side here, how to solve with a logarithm. Okay, so first step is we take log of both sides. So I write a step where I write down log on both sides. What this allows me to do is allows me to bring the exponent down. Okay, so I have x times log of 2 is equal to log of 7. Okay, now to get x by itself, we would divide both sides by log of 2. So I got log 7 over log 2. Okay, and then we just run that through our calculator. I guess I did it in 2 steps here, but if you can do it in 1 step, right, it comes out to about 2.8. Okay, so yeah, that's how you can solve the equation with logarithms. Okay, so that is your brief summary of the skills from the second part of Unit 3. Okay, what I want you to do right now, okay, is you should be working on either you can work on this practice work from the textbook. Okay, so starting on page 392, number 6 through 13. Okay, or I handed out a practice test on Friday, and there should be additional copies of that practice test on the kind of front left corner of my desk. So if you need one, you can grab one from there. Okay, but again, like previous units, your actual test will not be too far from the practice test. So that would be a good study guide for you. Okay, thanks for watching, and I hope to see you tomorrow.